All right, 5.8 inverse trigonometric functions integration. So first of all, let's recall inverse trig derivatives. All right, so hopefully you remember when we take the derivative of the inverse sine of u, or arc sine of u with respect to x, the proof that we went through, it's going to be u prime all over the square root of 1 minus u squared. All right. Very similar with the derivative of arc cosine of u with respect to x. The only difference is now it's going to be negative u prime all over the square root of 1 minus u squared. So you can see here that this derivative and this derivative, the only difference here is arc sine of u is positive, arc cosine of u is negative. And that's going to be the true for all of these cofunctions. All of the cofunctions, cosine, cosecant, cotangent, they're going to have a negative u prime, where arc secant of u, arc sine of u, arc secant of u, and arc tangent of u is all going to have a positive u prime. But everything else is going to be the same. All right, same thing. The derivative of arc secant of u with respect to x is u prime all over the absolute value of u times the square root of u squared minus 1. And then the derivative of arc tangent of u with respect to x is u prime all over u squared plus 1. And then I won't go through these two because it's the same thing as arc secant of u and arc tangent of u, the derivative of those, except it's going to be negative. All right, so integration would say if you have this, the integral of du all over the square root of 1 minus u squared, you're going to end up with arc secant of u. Okay, so integration involves inverse trig functions. Let u be a differentiable function of x, and let a be some constant greater than 0. Okay, so for number 1, if we have the integral of du all over the square root of some constant squared minus u squared, that's going to be equal to arc sine of u over a plus c. All right, number 2, let's say you have the integral of du all over a squared plus u squared. That's going to be equal to 1 over a arc tangent of u over a plus c. Number 3, if you have the integral of du all over u times the square root of u squared minus a squared, that's going to be 1 over a arc secant, the absolute value of u plus a, or divided by a plus c. Okay? Notice arc sine of x, the derivative of arc sine of x is 1 over 1 minus x squared, is 1 over the square root of 1 minus x squared. Thus, the integral of 1 over the square root of 1 minus x squared dx is going to be equal to arc sine x plus c. Also notice that the derivative of arc cosine of x is negative 1 all over the square root of 1 minus x squared. Thus, negative the integral of 1 over the square root of 1 minus x squared dx is equal to either negative arc sine x plus c or arc cosine of x. Okay? Conventionally, we use arc sine rather than cosine. A similar argument can be made by arc tangent of x rather than arc secant rather than arc cotangent and arc cosecant. So basically, we just use these three. Okay, going that way, or these three. All right, so let's try some of these. So part A, we need to figure out if we're using the rule, the integral 1 over the square root of a squared minus u squared du, which would be equal to arc sine u over a plus c. So we need to figure out if we're using that one or 1 over a squared plus u squared du equals 1 over a arc tangent u over a plus c. That one. Or the integral 1 over du u times the square root of u squared minus a squared is equal to 1 over a arc secant absolute value of u over a plus c. So first of all, does it look like one of these? A looks like number 1. Okay, where let 4 squared, well, let's do this first. Let's look at this as being dx all over the square root of 2 squared minus x squared. So a equals 2 and u equals x. So then if I plug it into this form here, this is going to equal arc sine of u, which is x, all over a, which is 2, plus c. That would be the answer for A. Look at B. So first of all, let's rewrite this as du all over square root of 2 squared plus 3x squared. So a is equal to the square root of 2 and u is equal to 3x. So now we're using this guy, and this will be equal to 1 over a, which is the square root of 2, arc tan of u over a plus c. Part C, let's rewrite this as 1 over x. Let's rewrite this as 2x squared minus 3 squared dx, and let a equal 3 and u equal 2x. So then we're using this guy. That's going to be 1 over a, which is 3, arc secant of the absolute value of u, where u is 2x, all over a, which is 3, plus c. All right, we'll stop there. Save number 2 for the next one.